Hi everyone. So we're going to start this video talking about our greenhouse effect. One of the terms you might hear with greenhouse effect is this blanket analogy. So that's really going to talk about how our greenhouse gases are kind of act like a blanket on our Earth because of it keeping the heat towards the surface of our planet here. So if we're taking a look at this reflection here, we see that this radiation is absorbed by the Earth, or it can be reflected out into the atmosphere, back into the solar system. But some of this radiation, if it's infrared radiation, is going to stay and bounce back and forth. As we can see right here, how it's coming down, bouncing back up. We lose a little bit of heat each time it goes up, but it usually stays and bounces in between our atmosphere and our Earth's surface, which is keeping the Earth warmer, which is very important to keep our consistent temperature that we have on the Earth. So some of our greenhouse gases that we're going to talk about is CO2, which is carbon dioxide, water, and methane here. So our greenhouse effect is a natural process where greenhouse gases absorb heat and release it slowly back into the atmosphere. So we're going to absorb some of this heat here, and it's going to sometimes go back into space, but then it's also going to radiate and get absorbed in the atmosphere to keep our temperature warmer around our surface. So greenhouse gases do not trap energy that has been converted to heat on the surface here. So it is going to radiate some of that heat to our surface of the Earth, but it doesn't necessarily trap it because there is still good possibilities of that going back out into the space. So our greenhouse effect is the warming of the surface and lower atmosphere of the Earth that occurs when carbon dioxide, water vapor, and other gases in the air absorb and re-radiate this infrared radiation. So that's going to be important. That's the type of radiation that's going to help heat the Earth here. So without this greenhouse effect, we wouldn't be able to exist with life on Earth because it would be too cold here for us to exist. So this really atmosphere, these different gases that help keep the heat close to the Earth are really important for that. So the most abundant greenhouse gases here are going to be water vapor, carbon dioxide, methane, and nitrous oxide. So these are going to be some of the most important gases that are happening in our greenhouse effect here. So the quantities of carbon dioxide and methane have increased really high because of industrial processes since the Industrial Revolution here. And we're going to talk about that a little bit. So when we're thinking about cars, so the reason our car gets really warm is because our sun passes through our car and it kind of acts like a greenhouse, if we've ever heard of that with plants. So the heat is going to stay right inside of our car here, especially with that black interior, because that's going to absorb that light rather than reflect it back out. So talking a little bit about some of the matter in the environment, we're going to talk a little bit about water. So talking about Earth's water, we're going to talk about our hydrosphere here. So our hydrosphere, it consists of our Earth's water. So Earth is made up of 97.5 is salt water and only 5.5% is fresh or unfrozen fresh water that we can use for drinking or watering plants, etc. So Earth's available fresh water includes surface and groundwater. So it's really important to note that we have such a little amount of usable drinking water because that's going to be really important when we're talking about third world countries and how they have that huge effect with drinking water here. So our water cycle is going to become very important when we're talking about Earth as a whole in our relationship here. So if we want to go through a little bit of what we're going to see here. So let's start from the bottom. So we have an aquifer here, which is going to be our groundwater reserve, really. So our groundwater is going to be used to water crops and or water land plants here. So if we're following our arrows, that's how we're going to use our groundwater. From there, we have transpiration, which is taking water from our plants on the surface of our plants, or we have evaporation, which is going to bring this water up into our atmosphere here. So we have evaporation from both oceans and rivers here. That brings the water up into our atmosphere. That leads here to precipitation. Precipitation both into our oceans and into our land here. So our land is going to bring us here to infiltration. So that's going to go back down and become part of our groundwater reserve. Or here, it goes back into our ocean and it's going to mix with our salt water. To talk a little bit more, just to zoom in a little bit here to our rivers. Our river system is going to be that 0.05% of fresh water that can be used for both human use, but there also are runoffs into the ocean to join part of that 97.5% of salt water here. So our water cycle is a continuous movement of water back from the ocean to the atmosphere and to the land back to the ocean. So it's really just a huge cycle bringing the water back to the ocean. But remember, some of that water is going to go into our groundwater reserve here. The water cycle is really going to be important too, because remember, water is one of our renewable resources. So it's something that we can continuously use and usually not have a big issue with that. The water pollution is going to be a very big thing coming through the current times. So just some terms here. Evaporation is the change of a substance from a liquid to a gas. So changing our water into liquid water to water vapor. Transpiration is the release of water vapor from plants through their leaves. Condensation is the change of a state from gas to liquid. So when you'll hear condensation, like if you have a really cold glass of water, you'll see some condensation on the edge of the glass there. So water vapor forms water droplets on dust particles, which is going to form those clouds, and droplets collide to create larger and larger clouds. And then eventually those drops are going to fall from the clouds as rain. So that's really the process of how that water vapor builds up so much in clouds to produce the precipitation that we're going to see. And our precipitation here is any form of water that falls to the Earth's surface. So that includes rain, snow, sleet, hail, etc. So runoff is water that flows over land and collects into a body of water. And groundwater, like I talked about before, is fresh water that is found beneath the Earth's surface. So that's the water that we're going to need to use for drinking and irrigation, watering plants, things like that. Okay, so we're going to end there. If you have any questions, make sure you reach out to me. Okay, I'll see you soon.